OpenAI just released their responses API, and every time OpenAI does something like this, the whole developer world panics, right? Because startups are getting killed, products become irrelevant, and we as developers have to study again to see what this is all about in order to stay relevant. And now the goal of this video is to make your life hopefully a little bit better, because I went through the entire thing and I'm going to outline it step by step, showing you exactly what you need to know about these new updates. So if you're new to the channel, welcome. My name is Ebbelaar. I'm the founder of Datalumina, and we've been building custom data and AI solutions for the past 6 years already. And we also run a community with over 100 freelance data and AI professionals. And I make these videos to help you level up as an engineer, so eventually you might want to join us. Now, let's dive in. So throughout this video, I will be walking you through this GitHub repository. It's in my AI cookbook, and there's a dedicated folder for responses. I will walk you through a bunch of files that you can also run yourself to experiment with this. Now, in this video, we are going to cover the following updates that are introduced with the Responses API. So, start with a simple introduction, really what you need to know. Then we'll talk about text prompting, conversation states. We'll see how you can now use function calling and structured output with the Responses API. And then we'll get into some new features, for example, the web search and the file search. And there are also some updated ways or improved ways that you can use reasoning models in this Responses API. And now every time there's an update within the world of AI like this, all YouTube channels, blog posts, news articles jump on it, usually with a lot of hype covering the low-level features that are already in the blog post. And my goal with this channel is always to go deeper than that and really explain what you need to know as a developer and how to translate these updates to what it means to build real AI applications. So hopefully I can do that and go a little bit deeper than most of the other stuff that you'll find online. But first, I want to cover the most important things you need to know as a developer right now. So these are just 7 quick points that I want to go through. Don't click off this video just yet. If you only get one thing out of this video, it should be this, and then we'll dive into some examples. So first, let's talk about the backward compatibility and where the new Responses API stands next to the Chat Completions API. The API that we've been using basically since the beginning of working with OpenAI models. And the Responses API is a superset of the Chat Completions API. And what this means in simple terms is that everything that you can do with Chat Completions can also be done with the Responses API plus additional features. We will cover those in a bit. Here's probably the most important thing to know as a developer. That is the migration timeline. In the introduction video, OpenAI announced that they will eventually sunset the Chat Completions API end of 2026. So there's still plenty of time, but you clearly see that the Responses API is the new direction, the new way forward for OpenAI, and it's going to become the new standard. So as a developer, you should already consider right now for the projects that you're working on what this means, what a migration timeline could look like. And for new projects, I would already recommend starting to build it around the Responses API. So keep that in mind. Now, what are those new features? And these are the features that we will cover in this video. So quickly, high level, there's a simplified interface for different types of interactions. So you can clearly see that the Chat Completions, when they introduced that API, it was really the first time doing this, and everything was based around chat and text. Right now, we have multimodal capabilities, and they have really simplified the interface, and it makes a lot more sense. There's now also native support for web search capabilities. Amazing feature, so we can browse the web. There is a new developer role that you can use. So next to System User Assistant, you also now have the developer role. We'll get into what that means. And then there's improved support for reasoning models. So there are parameters that we can tweak to control our reasoning models. We have built-in file and vector search functionality. And there's a simplified conversation state management that we can now use. Now, with this new Responses API, they also introduced some tools that we can use. So these tie into the new features, but there's web search, file search, computer use, and function calling. I will not dive into computer use in this video. So if you're looking particularly just for that, this is not the video. Everything else we will cover. Okay, so then when to migrate? I would recommend right now for new applications, new projects, start with the Responses API. Watch this video, understand what it's all about, and then for new projects, use this. For existing applications that really run and are in production, begin planning migration, but there is no immediate urgency right now. You still have probably 2 years to go. Test the new API in parallel with existing implementation to understand really what the differences are and how it might affect your outputs. Okay, now here number 6, this is a really important one. So the API structure changed. There's this new API that we can use, but really the same principles when it comes to AI engineering and when you're building applications remain the same. we're still using the same models. So for example, we're still using GPT-4o, and that model did not change. That model does not have new features. It's just that there are new features in the API. So features that previously required, for example, multiple LLM calls or a separate service or a separate function that you would use in your code can now be done in single API calls to OpenAI. And there are both pros and cons to this, which I will outline within this video. So while it overall makes the whole process of AI engineering simpler, it also introduces more abstractions because OpenAI is trying to take control of everything and really tries to vendor lock you in with being your one-stop shop for all things AI engineering. So really the fundamental patterns of retrieval tools and memory management still apply and they remain the same. So this new API, with it, there are no new features, for example, that you couldn't do 1 week ago. 1 week ago, it would just mean that you had to build some extra logic, some extra functions in order to make that happen. And right now we can do it with a simple API call. That's really what you should understand, because otherwise this update can feel very overwhelming. It can feel like, oh, there's all these new features and capabilities and how does it apply to my existing projects? You're probably fine. It's just an easier way to build these applications if you were to start from scratch again. All right, and then finally, let's talk about agents, because OpenAI also announced their new Agent SDK, which is going to replace Swarm. So you can find more about this on the specific documentation website, and we can even scroll down and come to the new open source Python library. So this is really a new library, a pip install OpenAI agents that you can use to build agents. This is similar to what Pydantic AI does, or what LangGraph does, or CrewAI, or plenty of all the other agent frameworks that are out there. Also, this Agent SDK will be beyond the scope of this video. So if you're specifically looking for that, this is also not the video, because we will first cover the responses and its fundamentals. And then in a later video, I will most likely get into what this new Agent SDK is all about and if it's any good and if I would recommend using it. All right, now let's dive into some practical code examples. So I am here in the responses folder and I am starting in the introduction file if you want to follow along. In all of the files, there are also links to the official documentation that you can reference. So for now, let's start with a really quick example to compare the chat completions API with the new responses API. And for this, I'm going to assume that you are already familiar with the chat completions API, so that you have worked with that and understand it. So we can do a simple API call using GPT-4o, write a bad story, and we get a response. Now, let's look at what that looks like with the responses API. So now, instead of using client.chat.completions create, we can use client responses create. So you can see that they have simplified the response creation, they remove chat, and another thing that we can immediately notice is that we now have this input variable. So in the chat completions API, the only way to pass data to the model is via the messages object, which had to be structured like this with the role and content in a dictionary, and then you could build a message history or conversation history. Now with the responses API, they have simplified this. And this is really a key insight, as really with OpenAI figuring out there's more to working with these AI models than just chat, right? A lot of the time it's just one sentence or one way you want to send information to OpenAI rather than having a complete conversation. So now it supports both. So what we can now do, let's run this and we will get the exact same response. We just have to input the model. And now we do as the input, write a 1-sentence bedtime story, and we get the response output.text. So they have also simplified the extraction of the key content that you want to get, where I found this always a little bit weird, where you had to do the choices and then the message and then the content. It just seems a little bit verbose, right? A little bit extra. Where right now you just get the response and you have the output text. And here you can see the output from the model. Now, like I've said, the responses API is a superset of the chat completions API. So everything that you could do in there is also possible over here. So here you can see an example of plugging in an image. So for the content, we put in an image. So this is a image over here. And then we can also let it describe what that is about. And it also supports streaming by setting stream to true, putting the input here. Let me just run this for you to go over this basic example. So you can see that we stream the output over here. So that's the very first introduction to the difference between using the chat completion and now the responses API. All right, and now let's cover example number 2 in the text prompting file. So next that inputs can now be a single string or a list of messages, we also have a new role, mainly the developer role. And there are 2 ways that we can use this new developer role. The first one is by setting the instructions. So this is a new parameter that we can now use. So here, for example, we could say, talk like a pirate. This would be an instruction coming from the developer to the model. But this would be similar to setting the role as developer. So this is the previous method of providing messages to the chat completions API, but the input parameter still accepts those types of message sequence, but you can also do a single string and then use instructions. So let's run these examples side by side to get a feel for that. So we can run this first example, talk like a pirate, GPT-4o, and then there's a question about semicolons in JavaScript. So there we get the response, but this would be exactly the same as setting the role to developer and then the content talk like a pirate. But you can already see this is a lot more concise, a lot easier to read and to manage than having the roles and instructions over here. So we can print the response over here, and you can see also a pirate explaining about semicolons in JavaScript. But now, here's something important. Because of this new developer role, you might be wondering, okay, but now what is the hierarchy? What is the role of the system prompt, of the developer, of the user, of the assistant? And OpenAI has an article on this, and specifically within this section called the chain of command, where they explain really the hierarchy of how different information is used to get to a final response. So there's a hierarchy to this, where, for example, a developer message overrides a user message, and a platform message, really what OpenAI is using behind the scenes, overrides a developer message. So let's see a practical example of what that could look like. But this article is also really worth going through and reading in full in order to get a better understanding of really how the API and the models work behind the scenes. But if I have the following example over here, so we use the responses API, we do a create GPT-4o, and there is a system prompt, a developer prompt, and the user prompt. And the system prompt says, talk like a pirate, and the developer says, don't talk like a pirate. Let's see what we get. And if we run this and then print response, you'll find that this talks like a pirate, because the system prompt is overriding the developer prompt to tell the model essentially to talk like a pirate. But now we can take this the other way around, where the system prompt says, don't talk like a pirate, and the developer says, talk like a pirate. And you'll find that it is exactly the other way around, meaning that this doesn't talk like a pirate. It just gives a regular answer. Semicolons are technically optional in JavaScript. So there is this new role category of the developer that we can use to play with. But the system prompt, the system is also still there. So what this means for you as a developer is that now, next to having that system prompt where you can control your application, you can also give more granular instructions on the developer role, but knowing that the system prompt will override that. But this could come in handy in certain situations where you don't want to really overbloat your system prompt, but just have a lean and minimal system prompt. But then for some occasions, have a developer prompt give specific instructions to make a certain situation or API call or prompt more specific with the context at hand. And then real quick, if you're a developer, you got some technical skills and you consider starting as a freelancer to take on some side projects, learn more, make a little bit more money, but you don't really know where to start or how to land that first client, you might want to check out the first link in the description. It's a video of me going over how my company can help you with this. We have a community with over 100 data and AI professionals, and we are all here to make more money, work on fun projects, and create freedom. So if that sounds like you, feel free to check it out, and then I might see you in a group. All right, now let's get into example number 3, and that is the new conversation state. So let's start with a simple example again. So before the response API, this is how you would manage your conversation and message history. You would have a sequence of user assistant, back and forth. And then every time you would make a new API call, the goal was to get all of the relevant context together and then create the message sequence and then send it to the API. And this still works. As you can see, it just follows up, knock knock, who's there, orange, and then the AI replies with orange who, correctly showcasing that it has the context on the joke that it is in. But now, here's the new way to go about this, and that is using the conversation state. So what we can now do is, if we use the response API and we ask GPT-4o Mini to tell me a joke, here we get a joke. But now what we can do, if we do another API call and we set the previous response ID to the response ID of the previous interaction with the model, and we can see we have this object. So let's see, we have this response. So this is the entire response that we got back from OpenAI on this call. And now we can specifically use the ID, which is a unique number over here, that is stored within OpenAI's platform that we can now reference. And if we then ask the model to explain why this is funny, so here you can see we have a single API call. We don't provide it with all of the previous context, and we ask to explain why this is funny. So this should now explain our previous joke. So why did the scarecrow win an award? So then it says this joke plays on the pun of involving the world outstanding, with the double meaning, right? So here you can see that it correctly referenced the context of the original joke, even though we did not specify that to the model, but it was able to retrieve that using the response ID. And now what's important to note here is that this storage is true by default. So we can plug in the parameter store is false, and this will not save it to the OpenAI platform. But if we leave this out, this parameter, we can use that ID, it will be stored, and we can use that in later conversations in order to pull that up. So that's going to overall make your life as a developer easier, but it can also be tricky for debugging things because this is all stored within the OpenAI platform, and having something explicitly like this or building it really specifically like this can have an advantage from a developer perspective if you're going through a code base, because someone new to this project might be like, okay, but where is it getting the context from? And also, where is it stored? How long is it stored? Those are all things that you should really be familiar with before really using this response idea to manage conversation history. All right, and then number 4, function calling. So with this one, I'll quickly go through it because it's essentially exactly the same. We specify a function in the form of a tool. I'm not going to dive into the specific syntax and how to do that because I've highlighted that in other videos, but it's exactly the same as it was with chat completions. So you can specify the model, the input, and then you just specify it as tools. So here's a tool that sends an email, and we ask, can you send an email to Ilan and Katja? And we can look at the response, and we should get 2 objects back. So this is the first one and the second one. So this is an email to Ilan, and this is an email to Katja. So for function calling, nothing really changed. You can just specify the tools and add it to the API call. Okay, and then number 5, structured output, because any serious AI application needs structured output to some degree. So let's cover the 2 examples that you can use, and I'll have a sneak preview here for you that I wasn't able to find. I really had to do a lot of digging for that because whenever I use structured output, I typically either like to use the instructor library or use OpenAI structured output, but then use the Pydantic version of getting structured output over specifying the JSON schema. And if you go into the documentation right now, you can't find the Pydantic documentation on how to do that with the responses API, but it still works. I found a message from an OpenAI dev and I'll share it here as well. But there are 2 ways that you can use the responses API to get structured output. So that's by specifying a JSON schema. So again, model, we specify the input, and then we put text in here and we format that. So in this case, we say that it's a calendar event and there are properties. So it's a name, date, and the participants. And we use this to look at a message and extract the name, the date, and also the topic. So what the event is about from this specific text. So this is again similar to what it was with the chat completions API. So we can run that, we can load it, and we can have a look at the event. And now we can see that we get a JSON object with name, science fair, date, Friday, and the participant is a list with Alice and Bob. So that's how it's specified over here. But like I've said, I always like to do this directly with Pydantic models. So instead of having this very verbose JSON schema definition over here. Let me just define a Pydantic model and use that. So that still works. So here's the link to that. I found this link where someone was saying, I wonder why they phased out Pydantic structure output for the responses API. Let me show that over here. And then what is it over here? This guy. So shout out to you, Steve, from OpenAI team. He linked to this GitHub example and it still works. So what it then looks like is you can also just specify your Pydantic model, and then we have model input instructions, and then text format, we do the calendar event. So let's put that in here. Then we get the response model, and now we can get the actual Pydantic model by using this syntax over here. So we do have to do a little bit of digging onto the object that we get back in order to get the Pydantic model back. But here you can see now we have this exact Pydantic model, the calendar event like we specified. All right, number 6, web search. Really cool and very simple to use. We can now use a tool called web search, and we do that by specifying the tools and then setting type to web search preview. And we can just hand that over to the API. So the responses API, GPT-4o, we ask what are the best restaurants around the Dam, which is a place here in Amsterdam. So I can run this, print the response, and this will take a little bit longer because it's going to actually perform Google searches and browse the web. And then here you can see the Dam located in the heart of Amsterdam. And then we have a couple of options that we can choose from. Now, if you go into the specific documentation, you'll find that there are some more options that you can play with. One thing that could come in handy is specifying the user location, because doing searches, especially Google searches, it really depends on your location to see what kind of results you get. So that's how you can do this. So I can run that. It would be similar. We would get a similar answer. And then what's also cool, the annotations are also in there. So let me pull this up over here. So you can see all of the sources that were used. And in there is also a URL. So if I just look at the first object over here, you can literally see this source was used to base its answer on. And that's really cool that we now have this feature right out of the box within the OpenAI API. Okay, now number 7, file search and semantic search straight from the OpenAI platform. So I'm not sure what I think about this. So with this approach, you can essentially perform RAG and do it all using OpenAI. But there are so many great tools, open source vector databases already that can do this as well. So doing it directly in the OpenAI platform, I could definitely see how it makes it a lot easier for a lot of developers. But really, if you're serious about building AI applications, then I would really be hesitant with using this feature out of the box, because it's pretty straightforward to build yourself and you'll have a lot more control. Because as you'll find, some of the things you just have no control over. You're not really sure where your data is, how it's chunked, etc. But it's cool that it's there nonetheless. So let's have a look at how this works. So for this, we use a little bit more than just the responses API, because we are first going to upload a file, create a vector store, chunk it, and then perform the similarity search on it using the responses API. And these are all examples really from the OpenAI docs. So I'll just run you through an example over here. I think with this, the best is just to experiment this on your own and run the code. But first we can create a file. So we have a URL over here. So this could be any file or URL. And what you can do is you can come to the OpenAI platform, and here you can see all your files. So you can see I just uploaded this deep research blog.pdf. So this literally is a public URL, public PDF, and you can plug in any URL or file path, and it's going to upload that to OpenAI. So here you can see in the platform, we now have the PDF in here. Then we need to create a vector store. So again, there's documentation in here on what that looks like. And here you can see we don't have one yet, but we can use the API to say, let's create a knowledge base. So now if I refresh this, we have a knowledge base. Great. Now we can add the file to the vector store. So we use the file ID that we stored over here, and we can run that. Let's see. All right. So we put that in. We can check the status. It's probably already complete. All right. And then let's have a look at this knowledge base. So now you can see that within this knowledge base, we have the file deepresearchblog.pdf. You can see the usage, the size, etc. And please be aware, this costs money. So whenever you have a knowledge base that is active, you will be billed per day. So if you run some experiments and you don't plan on using it afterwards, make sure to delete them. And now what we can do is we can use the responses API and we can ask, what is deep research by OpenAI? And then we have the tools and we say type file search, and we have to plug in the vector store ID. So this is the ID of the knowledge base or the vector store that we just created. So let's run that and see what that looks like. So what this is now going to do, we're going to use the response API. We ask what is deep research by OpenAI. We give the tool file search, and because it has that context, it's going to decide, let's use that knowledge base to perform a similarity search on. And then you can see over here, if we have just the text, it can tell you what that is, and it will use information from that blog post. Now, one of the things that I always find a little bit tricky with this, so okay, we have this in here, but we don't know how this was chunked. We don't know what embedding model we're using. So while it's very simple and straightforward to get started, you also lack a lot of control as a developer. And I, for example, have a lot of videos on this channel on how to build RAG systems. It's all pretty straightforward to set that up. It's really hard to scale and do it well and avoid hallucinations really at scale as your knowledge base grows. And with this, you're going to run into similar issues, especially since you don't have that much fine-grained control. So what you can do to limit the results is, for example, you could set the maximum number of results or chunks that are retrieved from the knowledge base. You can set that. So for example, we can set that to 2. And then we can also include the search results. So this is some syntax from the that you should just get from the docs, or you can just copy it from here. But if we set it like this and we print the response model, so this is the same question. What's deep research by OpenAI? It will run, it will print, and here you can see over here that we have the results and that you can see 2 chunks over here. So we set the max number of results to 2. And here you can see, so it has the score. So it's file name deep research blog.pdf here as well. But these are just referencing to different chunks of that PDF. So when you upload it to the vector store, OpenAI is going to chunk it up. And that's why you get these different pieces. And this is how you can control and limit that. All right, and then lastly, let's talk about reasoning, because right now, if you use a reasoning model, you can also plug in the reasoning parameter and you can control the effort, which you can set to low, medium, and high. So if I plug this in here and run that, you can see it will take some time for this to finish because it's now going to perform that reasoning. And depending on the effort that we set, this is going to take longer, it's going to cost more. And this is an optimization game, right? Do you want more reasoning, meaning higher tokens, more cost, more latency, or is a shorter duration also fine? And here you can see we have the entire output of this problem over here that we're trying to tackle. So very quick, simple update, but also available within the Responses API to control reasoning models. All right, and that's all you need to know about the Responses API as a developer. Now, while a lot of these features can make your life easier, I would also be careful offloading all of the logic to this OpenAI API, because yes, it's easy, but it also becomes yet again this black box where you are not entirely sure why it made a certain decision or why it's calling this tool. And real AI engineering is all about getting the right context and information at the right time and sending that to the model. And the more control you can have over that, the better. And this just introduces a lot of abstractions in a way that can make debugging and finding edge cases really hard. And also one of the major challenges that a lot of AI engineers struggle with is, okay, this is great, this works locally right now, but how do I really put this into an actual application that I can put into production and that customers, clients can actually use? And for that, we have developed our generative AI launchpad, which is our production framework. So this is not really about building agents or calling the LLMs, while that is integrated in here as well. That is much more about the infrastructure that you need in order to put AI applications into production. It's a boilerplate that we use for all our agency projects, and we use this as a starting point. So if you're interested in this, check out the link in the description. This can really shave off 90 hours per project. At least that's what it does for us right now. So with that out of the way, if you found this video helpful, please leave a like and also consider subscribing. And then if you want to learn more about building AI systems and building AI agents, I highly recommend to check out this video next, where I cover how to really build AI agents in pure Python. Really the fundamentals that will stay the same, that don't change, and it will really help you to become a better AI engineer.